Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, in the last session we studied how the discovery of electron happened. In this session we are going to learn about the discovery of proton by discharge tube experiment. But yes, before starting with the new topic we have to revise the last session that we learned about the cathode ray experiment to discover the electron by Sir J.J. Thomson. This is the apparatus used for the experiment, where Sir J.J. Thomson studied the characteristics and constituents of cathode ray, which are electron. This apparatus is called the discharge tube, or you can also say it as a cathode ray tube, just because the cathode rays are formed in this tube. The conclusion by this experiment was, first of all, the cathode rays consist of negatively charged particle. We call it electron. Secondly, the negatively charged particles are an integral part of all atom. That is, all atom contain electron. The electron have both definite mass and definite electric charge, both of which are actually independent of the nature of the gas in the discharge tube. So the relative charge of an electron will be -1, or you can say the magnitude is minus 1.6023 into 10 to the power minus 19 coulombs, and the mass is the 1/1840 times the mass of the hydrogen atom. So let's come up to the new session with the discovery of proton, where we are going to understand about these subtopics. So let's start one by one. Discovery of proton by the person who is a German named Eugen Goldstein. In 1886, Goldstein noticed that when a perforated cathode, that is a cathode electrode with its holes, was used in the discharge tube, the another set of rays traveling in a direction opposite to that of the cathode ray, that is, from anode towards cathode. These rays are called positive rays, or you can also say the anode rays. So let's start with the construction. So this was actually the discharge tube which was used in discovery of electron as well as in the discovery of proton. There is a slight change in the apparatus. Let's take a marker and understand the change. We all know that this is a discharge tube, right? Made up of glass. These are the electrodes, the metal electrode, right? This is the cathode electrode, basically, the negatively charged electrode. And this is the positive one, positive electrode. We call it anode. This is a high voltage generator. And this is a vacuum pump used to manage the pressure in the tube. There is the pressure of a gas in the tube, right? These are basically the positive rays coming from the anode side. We also call it anode rays or the canal rays, right? So what is the difference between both of the apparatus? Let's understand by giving a different. You can see here the cathode electrode is kind of a perforated cathode, What is perforated cathode? That is cathode with holes, right? So this is the kind of apparatus was used for the discovery of proton. Let's come to the working of the cathode, the perforated cathode. Why it is actually used in this apparatus to discover the proton. We can see here the working. See, we just saw the diagram like this. This is a perforated cathode, that is a holes within it, electrode having a holes. This is a positive, this is a negative, connected with the high voltage generator. And here are the positive rays coming from the anode side, right? And this shall be the vacuum pump, right? And there is a gas in the tube with a very low pressure, right? So what happens is now, first, high voltage of about 10,000 volts is being supplied to the discharge tube, where the electricity has been generated, that is the electrical energy is generated, and the rays comes out when the pressure is minimum. That is, the pressure is about 0.001 mm of mercury. So at this pressure and at this voltage, what happens is, in the apparatus, there's a production of positive rays, a discharge tube having a perforated cathode ray, which is used here. This cathode having a holes in it. The perforation or the holes are to allow the positive rays to pass through them. When a high voltage of about 10,000 volts is applied to a discharge tube having a perforated cathode and containing air at a very low pressure, about 1.001 mm of mercury, there is a deflection here, that is, there is a red color, red glow, you can say that. Here is a red glow which appears at the end of the tube after the cathode. So it is now known that some rays are formed at the anode, and when these rays strike the walls of the discharge tube, they produce a faint red light. Since these lights are formed at the anode, that's why this is called an anode rays. Let's write down. Rays, that is a positive rays formed by anode side, therefore it is called anode rays, right? Or you can also say the canal rays. So here's the working. You can see the diagram again. Let's understand the diagram again. Here's the diagram, and here is the red glow. which has been generated. Here it see, this is a red glow which has been generated here, right, at the end of the discharge tube. Now let's come up to the properties. So how the anode rays are formed? That is it is basically a process. That is, when high voltage of electricity at very low pressure, that is 0.001 mm of mercury, is being introduced in this discharge tube, there's a faint red glow observed behind the cathode, right? So it is said that the positive charge particles from anode rays or the positive rays are formed, which makes the glow at the beyond the cathode. So the anode rays consist of positively charged particles formed by the removal of one or more electron from the gas atom. Let's understand the explanation of this conduction of electricity through the gases. That we call it that the gas taken in the discharge tube consists of atoms, right? When we apply high electrical voltage, the electrical energy splits the gas atom into negatively charged particles and positively charged particles. The negatively charged particles form cathode ray and the positive one form positive rays. These negative and positive particles conduct electrical current through the discharge tube. There comes the formation of negatively charged cathode rays and the positive rays from a gas, which tells us that an atom contains two types of particles. There is first is the negative particle, second is the positive particle. So here in this experiment, when the gas in the discharge tube is at the atmospheric pressure, then there is a large number of gas atoms in the discharge tube, right? These gas atoms collide with an electron and prevent them from reaching the anode. Since no electron reach the anode, no current flows through the discharge tube. So if we decrease the gas pressure, then there are very few gas atoms in the discharge tube. Since the number of atoms is small, there is no hindrance to the movement of electron and gas conducts electricity, right? So this is actually the theory behind this whole experiment, in the experiment of the cathode ray experiment and also in this experiment where the discovery of proton has been invented. So now let's come up to the properties of anode, which is more of the similar to the cathode rays. So first is the anode ray travels in a straight line, as we have also proved in the last session about the cathode rays. They also travel in the straight line. Anode rays can produce mechanical effect as same as the cathode ray effect. If you want to prove the anode ray can produce mechanical effect, you can use the proof which we have already given into the last session for the cathode rays. The cathode anode rays are positively charged, and the nature of the anode ray depends on the gas taken in the discharge tube. Last but not the least is the mass of the anode rays particle is almost equal to the mass of the atom from which it is formed, right? So let's come up to the characteristics of the proton. Let's take the marker. First of all, the mass. What is the mass of the proton? The proton is actually hydrogen atom, that is right? Which has lost its electron. That is, with no electron, since the mass of an electron is very small, we can say that the mass of proton is equal to the mass of the hydrogen atom. That is if we write like this, proton is equal to the mass of hydrogen atom, right? That is 1 AMU. So the relative mass of the proton will be is 1 AMU. As simple as that. In last session we have seen that electron, that is the mass of electron, is 1 by 1840 times of hydrogen atom. So here we can understand now that the mass of proton is 1840 times the mass of electron. Therefore we can say that the absolute mass is 1.6 into 10 to the power minus 24 grams. This is the absolute mass of the proton. Right? Now if we come to the charge of the proton, the charge of proton is equal and opposite to the charge of electron. In last session we have seen that the electron charge have 1.6023 into 10 to the power minus 19 coulombs, right? So what is the charge on the proton? That is the 1 point, this is negative, 1.023 into 10 to the power minus 19 coulombs of positive charge. And the proton is, that is the relative charge in the proton is plus 1, where the electron is having a minus 1. So it is very simple to understand that the charge of the proton is equal and opposite to the charge of an electron, just because electron is a negatively charged particle and proton is a positively charged particle. So the absolute charge of the particle is positive 1.6023 into 10 to the power 19 coulombs, and the relative mass or relative charge of the proton is plus 1, where the electron is a minus 1. So here we can now characterize the proton with mass and charge, which is the positively charged particle founded in the atom, in basically the nuclei of the atom of all the elements. And only hydrogen atom contain one proton in its nucleus. So atom of all other elements contain more than one proton. So by this experiment, what do we conclude in a whole? Let's pen down the conclusion and the main points. First, that the anode rays are positively that is the constituent of the rays. Second, anode rays are also called canal rays or the positive rays. Third, we also understood that the proton have the relative mass that is 1.6 into 10 to the power minus 24 grams, and the proton with the relative charge is equal to positive 1, or also say that the charge of the proton is positive 1.6023 into 10 to the power minus 19 coulombs, right? We also have seen in this experiment that the proton is somehow also called the value of hydrogen gas. What does this mean? That the hydrogen with one proton is also contained as a proton, just because the mass of the hydrogen is equal to the mass of the proton. So here I conclude the whole experiment by the property of proton, which has been discovered in this experiment by the Goldstein in 1886, with the cathode electrode having holes in it, and the proton, which possess a unit positive charge with the value of 1.6023 into 10 to the power minus 19 coulombs, is a positive charged particle present in the atom of every element. So this I close, or the I end up with this session with the discovery of proton. I hope you have understood all the points one by one, from the construction to the conclusion of the discovery of proton. Now you have to do is an activity. You just need to give me 3 differences between the electron and proton in 5 minutes. Thank you. So end up now we shall meet with the topic that is of discovery of neutron. Thank you friends for attending this session and making this session complete and wonderful. Thank you. Thank you friends.